Hi, welcome back to our video. So before we proceed in our first example in finding the area of region bounded by the curve, then let me discuss the general procedure in finding the area. First is you need to sketch the area to be found, of course, for have an illustration of the area that we need to be found, and of course we need to label it with some important points in our problem, and then show the representative strips, and later on I will uh, give you an example regarding this or yung tinatawag natin na element. Okay, and then the next step is to approximate the area by assuming that last time we discussed that it is a rectangle with area which is equal to length times width, right? And then we let the area of the element be equal to the dA, or the derivative of A. And then the third step is to get the area of the region by integrating this dA from the lower limit to the upper limit of our given sample. Okay, so to further illustrate to this general procedure, let us now go to our example 1. So let's find the area bounded by the parabola. So we have a parabola given by this equation: y is equal to x squared plus 1, and then and x-axis line. So we have the parabola and the x-axis line with x is equal to 1 up to x is equal to 3. Okay, so in order for us to see which area are we going to find, then first step is to sketch it. We have the curve and we have the line. So we can now have the area bounded by this two given points here. So we need to sketch this parabola. Okay, so from your precalculus, let's try to sketch this parabola. So by doing that, you can assign some values of your x and y, and then graph the points, right? So maybe around 1 2 3, enough points to just show our parabola. Okay, so since we have this line here, x and y axis, let's try to find points equivalent to this points also, right? So let's start with maybe say let's say from 0. Let's try from 0 0 1 2 3. Okay, so if x is to 0, then our y is, if x is 0, x is 0, then our y is equal to 1, right? If our x is equal to 1, 1 squared plus 1, our y is equal to 2. If x is equal to 2, then we have 2 squared, 2 squared 4 plus 1, we have 5. If x is equal to 3, we have 3 squared, 9 plus 1, we have 10. Okay, and then let's extend our points. Say we have x is equal to 4, we have 17, right? Then what else? let's have another point to uh, show our parabola. So sketch our parabola. So let's try from since we have here 1 2 5 10 7 0. Let's try negative values. Okay, from negative values, so we have 0, negative 1, negative 2, 3, 4, negative 5. So let's try this one. So if we have points negative 1, if our x is negative 1 squared, we have 1 plus 1 equals 2. We have negative 2, we have negative 2 times 2, 4 plus 1, also 5. So for 3, negative 3 squared, we have 10. Negative 4 is, we have 17, right? So let's delete this one. So I think that's enough points to sketch our parabola. So let's try to sketch it. Let me sketch it in this side. Okay, assume that my line is straight. Then we have 0 1 1 2 3 4 5 1 2 3 4 5. For y, say we have 2 let me change my values. Say this is 2 4 6 8 10. So we have 2 4 6 8 10 and so on. Since I don't have enough space, so let me use this points by 2's. So if our y is 1, we have x is equal to 0. So y1 x equals 0. We have point here. If x is equal to 1 or y is equal to 2, sorry, y is equal to 5 or x is equal to 2, we have 3 and we have 10. Is this 3? And then for 4 we have 17. Next, and for negative 1 we have 2. Negative 2 we have 5. Three we have 10. And 4 we have 17. So I think our parabola looks like this. And